Hello guys and welcome back to another video. Today we're going to be proving that the derivative of sine x is equal to cos x. Alright, so let's start out by first writing out the first principles of differentiation, which states that the derivative with respect to x of a function f of x is equal to the limit as h approaches 0 of f of x plus h minus f of x upon h. Now, if you want to see the proof for this, I will make a video on this soon, inshallah. Okay, so let's say that our f of x is equal to sine x. So we want to find the derivative of sine x. So we get the limit of h approaches 0 of f of x plus h. And remember, f of x is sine x. So we have sine x plus h minus sine x upon h, right? And now let's write down a note which states the compound angle identity for sine. So let's say we have sine of a plus b. This is always going to be equal to sine a cos b plus sine b cos a. All right, so now let's just write this down. The limit as h approaches 0 of, let me write this in a different color so you know what's going on, sine of x cos of h plus sine of h cos x minus sine x all upon h. All right. Okay, so now look here, we need to see the trigonometric ratios that are being affected by h, namely the cos h and the sine h. So we need to figure out what the values of cos h and sine h are. So let me just write these separately. So the limit as h approaches 0 of sine h is equal to h. All right, and let me put up a graph of sine x. And look here, as the angle gets smaller and smaller on the sine graph, the height matches the angle. Therefore, sine x is equal to x when x is small, or the limit as h approaches 0 of sine h is always equal to h. Similarly, the limit as h approaches 0 of cos h is always equal to 1. Let me put up a graph of cos x, and you can see as the angle gets smaller and smaller, cos x reaches 1, right? So now we understand that cos h is equal to 1 and sin h is equal to h. So we can write this down. So the limit as h approaches 0 of sin x cos h, and cos h, remember, was just 1, plus sin h, remember sin h is h into cos x minus sin x all over h. Okay, so look here, the sin x and the negative sin x cancels out, so we are left with the limit as h approaches 0 of h cos x upon h, and the h cancels, so we are left with the limit as h approaches 0 of cos x, and this is obviously just equal to cos x. Therefore, the derivative of sin x is always equal to cos x. Let's box this and make a small box here showing that we have proved this. And as always, if you like this video, don't forget to like, share and subscribe, and I'll catch you in the next one, inshallah. Allah Hafiz.